This is the second video about the low voltage network, where I'm gonna explain, this time I'm gonna explain about some more special cases where the utilities use some cabinets that are a little special. And this is where what we're gonna have to support in the app. Currently we cannot support that directly, but we have to make some functionality so it's easy for them to kind of register this kind of situations. And I'm gonna try to explain how it works, and hopefully it's enough information for you to kind of extend the app to support this stuff. Okay?
Mm.
Yeah. And so here I have drawn like a normal, very simple low voltage bus bar circuit inside a cable box, right? So here we have some kind of, you have 4 whatever lines that is connected to a bus bar, and 2 of them is connected as a fuse switch disconnector, and 2 of them are just connected directly to the bus bar. Okay.
Mm.
So this is a typical thing we will see when we have a normal cable box somewhere. Then sometimes they have some cable boxes who has something known as linking knives or adjustable knives or something like that. And what that is, it's a little difficult to explain, but maybe I should try explain how it works in real life. I have drawn this drawing here. Can you see this? Yeah. You can imagine there goes 2 cables inside. This is a cable box, and you look inside it.
Mm.
And we have, here we are seeing the real life stuff, so we see the 3 phases. There's phase A, B, and C, and this is a neutral line. And where in the single line diagram we only see the 1 line for representing all 3 phases. Okay, so don't get confused about that. Also, this cable of course has several wires inside it, 1 for each phase, that connects to this here. But in the single line diagram we only show it like 1 line, right, and 1 fuse.
Mm.
Don't get confused about that. What these special cabinets can do is that they are able to kind of use some equipment, and then they can kind of decide if this phase here, this cable is connected to the bus bar, or it should be connected to the neighbor bay, right? Can you imagine they can actually move, they can turn some metal and kind of change the connectivity inside the cabinet. So for example here, if this wire is connected to the bus bar, this wire is connected to the bus bar, this wire is connected to the neighbor because they have connected these 2 together. Does it make sense?
Yeah.
So the power goes up here and bypass the bus bar. Actually, this is normally they will all do it the same, right? But they will do it gradually. They will take 1 phase at a time and disconnect it and connect it to maybe the neighbor bay. There's video on YouTube here, you can see. If you search for ABB FD3300, you can see an example of how they do that, how it works. ABB is one of the manufacturers who create cabinets that can do this. They create some modules you can put inside the cabinets, and then you can do this. Other manufacturers do it differently. Some manufacturers have cabinets that this is kind of built in all the ways, so you can do that. But the principles are the same. The idea is you can disconnect the power from this cable to the bus bar and instead kind of redirect it to the neighbor bay instead. So you can bypass the bus bar. That's the whole idea. The way we can show that in a diagram is, my idea is that if you have a normal cable box and you have this bus bar circuit inside the cable box, and we'll put a Boolean attribute on the class inside the data model, and in the app you should be able to choose if it has linking knife or not, yes or no. And if you say yes, we will kind of put some stuff on top. You can imagine we kind of put something in between here, the bus bar here. So the orange stuff here, we add. Does it make sense? Like we basically move this down and put all this stuff inside it. This is the idea is then that the user can choose to open or close this thing here, this switch. You can think of them as switches, and they can also choose to open or close here, so the power goes this way. Okay. So I'll give you. This is actually I'm trying to give you a concrete example here. So if this cabinet here is fed from station 1 and station 2, so there goes a cable inside this bay and a cable inside this bay. So it's actually fed from 2 different places, right? Then you might have a situation like this, where they have connected this bay to the bus bar, right? So station 8 is feeding the bus bar, and you can see the power runs here, cannot go down here, it's disconnected. It cannot go down there, can disconnect it. And here's the connection, and it will go down. So this normal customers or whatever get fed from station 1, right? Then they have chosen to say, okay, we have station 2, it comes into this bay, and then they choose to connect it to the neighbor bay like this, and the neighbor bay is not connected to the bus bar here. So actually this VIP customer gets power directly from this station, okay? Because they have connected like this. Then whatever happens, something happens in real life, they have to do some maintenance, they have to, something, broken cable is, someone dig into the cable, whatever. So then they can actually do things. They can actually, let's say they want to, what should we say? This substation here, they want to do something with this substation, but I don't want this VIP customer to lose power, right? Then they can actually switch over so that the VIP customer gets power from this one instead of this one. By using these cabinets, by putting these knives in and moving these knives, you can actually do that while the cabinet is energized. This is an example of what they can do. They can use it in more advanced examples, like in cities where they have a lot of lines going together, and they can kind of change the way the power flows in the low voltage network without even de-energizing the cabinet. The customers. They can also de-energize the bus bar and in the whole cabinet, and then maybe they have to do something with that one and put some extra on or something like that. So there's a lot of possibility when you have this type of cabinets. So, but from a app perspective, from a data model perspective, actually it's quite simple. So the idea is, if you choose to say this cabinet is of this special type that have these linking knife, I call it that. This is what ABB call them, so I just call them that. I think some other manufacturers call them something different. It doesn't matter. We will change this to Danish. Anyway. So then if you choose yes to that, you will get this extra layer in the diagram, and then you somehow has to be able to click that bay and tell that if it's connected or not to the bus bar, and you also somehow have to be able to tell in the app that if there's the connection to the neighbor bay here, and I'm not sure how to do that the most user-friendly way, so that's up to hard to figure that out. But the way to visualize it in like a diagram like this, I think will be easy understandable for the people in the field, because they know when they see this stuff, they know, okay, we are dealing with this kind of special cabinet where we can do stuff like this, and it's easy to them to see how it's currently configured. And if they change something in the real life, they can go in and tell what they changed. So, but look at this video. It will give you an idea what they do in real life with this. There's some example with a guy who kind of switches this thing, do some switching using this thing, and then you better understand how it works. And hopefully, yeah, this is not enough information to make the functionality in the app. So yes, okay.